So now we're gonna use our prior knowledge to help us graph this rule that we have here. So we're gonna do that with our table. So we're gonna graph using a table. So here is my rule for this function. Our function is called s of x. So let's look at the table now. Your first row is your input values. Your second row is your output values. So let's look at our inputs. So we have 5 different inputs. That means we're going to have 5 different outputs. So what we're doing is what we did in the other video, where we were evaluating a function at different input values. So I'm going to set it up the same way. I'm going to have a setup for each space where I'm going to work out each of our calculations for each of the input values. So we have s of -4. We're going to evaluate s of -2, s of 0, and s of 2, and s of 4. And I know that I wrote s of 0 twice, but I'm going to change it later to s of 2. Okay, so for s of -4, -4 is going to go into my rule, which means our x is going to be substituted with -4. Everything else just remains the same. So the 1/2 is going to get distributed into -4, which means multiplication, but it's easier to read it out loud. So 1/2 of -4 is -2. And we simplify that, so s of -4 is -4. So our input is the same as our output here. Let's go ahead and see if the same thing happens when we input -2 into our rule. So inside the parentheses will be what we're substituting for x, which is not -4, right? Because it's s of -2, so it should be -2 for our x. Same thing, we're going to distribute the 1/2 into the -2, which is -1. Bring down the -2, so that gives us -3. So I guess the input and the output being the same only applied when x was -4. Let's go ahead and do it for s of 0. But like as I mentioned earlier, if you can do this mentally, then you can skip the calculation step and you can just do your calculations mentally. And like I told you, 0 was going to be the easiest because the only thing left would be -2. And later you're going to learn what this is called. And as mentioned, I'm going to go ahead and change it to s of +2 because we already did the 0. We don't do it twice. And I'll do some mental calculations here. So if 2 goes into my rule, meaning x becomes 2, then what's going to come out is 0. Let's go ahead and fill in our rest of our table with what we have. All right, so now that you have your table completed, we're going to plot them in our table as ordered pairs. So my first order pair is -4, -4. So we always start at the x-axis and then we go to the y. The next order pair will be -2, -3. So we're going to start at -2 on the x-axis and we're going to go down to 3. The next one will be 0, -2. So we start at the origin, which is right at the center on the x-axis, and we're going to go down to -2. The next order pair would be 2 and -1. So we start at +2 on the x-axis, and we're going to go to -1. And our last point would be 4, 0. We're going to connect them with our line since this is a linear function. And let's go ahead and label 2 specific points that I just circled on the table. When it crosses the x-axis, that's called the x-intercept. And later, we're going to learn how to graph linear functions with our intercepts. So it would be helpful if you guys are able to identify them moving forward. Where it crosses the y-axis is called the y-intercept. So now you guys know how to graph using tables. So that's how we're going to start graphing equations or linear functions in this case with tables. And then move forward to using other techniques.